So our next topic is chapter 3, decision-making statements. So let's get started with that. In programming, in the past, you only wrote programs that that will do just some calculation, simple calculations. That's about it. But there are a lot more complicated situations that we have to write program for. And we're going to learn those other techniques starting from here. In this chapter 1 and 2, we did just the foundations of computer programming. You need that foundation to build on it, to go on and understand the rest. So that's why I said, if you did very poorly in the first test, I mean, if you were around 50 or so, then you may be okay. But those students with their 20s and 30s, they should reconsider continuing with the class. You may be wasting your time. If you're obviously not going to do well in a class, it's better to drop that and use that time and effort on another class. That's recommended. So you may want to reconsider if you got real bad grade. If you want to talk about that personally, you can come into office hours or request a personal meeting. I'll set up a personal meeting to hear what you have to say and discuss the details of your test and things like that. Feel free to do that. All right, so these decision-making statements will make system make a decision for us. Decision means simple decision, like compare something or check something, and if certain condition is true, then do certain statement, and if the condition is not true, then do something else. It's just that sort of decision. We can have the system make such decisions. So here is, so you're going to understand such decision-making statements, and the kind of statements we are going to discuss are called if statements and switch statements. We are going to do both. So let's begin with the if statement. The if statements basically say, if certain condition is true, then do this statement. The statement, as you can see, the semicolon is only, there's only one semicolon after the statement, because this whole thing is one statement. You could write the whole thing in one line, but we break it into two lines, and also we indent the second line. You can see that there are some blank spaces here. The second line is moved in by about 3 or 4 spaces. And when you write this if statement, you're supposed to follow the same rule. The statement should be moved in so that somebody reading it can easily see what statements will be executed when the condition is true. That's why we write it that way, for easy reading. So if, and then the parentheses is required, and you write the condition inside the parentheses, and then you write the statement that should be executed when the condition is true on the next line, indented. If you have many statements to do when the condition is true, then you will write it this way with the brackets. Only if you have brackets, then all of these conditions, all of these statements will be done as a result of getting true for the condition. If the condition is false, it will not do any of them, and it will move on to the next statement in the program. So here also in the first case, if the condition is not true, the statement will not be executed. It'll go on to the next line of the program. Now, if you miss the bracket, which is a common error in programming, many students often do that. If you miss the bracket, then only this statement is part of the if. Part of the if means it'll be executed as a result of getting true for the condition. This statement will be executed regardless of whether the condition is true or not, because that's outside the if now, if you don't have the brackets. So if the brackets are missing, only one statement is inside the if, others are outside. So make sure to put the bracket when you have more than one statement. Okay, so we need to understand what will happen. it will evaluate when an if statement is executed. The first thing it'll do is evaluate the condition. If it is true, then it'll do the statement. If it is false, it'll ignore the statement and go on to the next. Same thing here. If the condition is false, it'll ignore all of this and go on to the next. Okay, so formatting rules. You need parentheses around the condition, but the statement could be written this way. If condition and then statement, semicolon. This will be accepted by the compiler, but it is not acceptable for the programmers. You're supposed to practice the rule for the programmers, which allow other programmers to read program easily, which is to write it this way. Break it up and write them on separate lines with the indentation. The indentation is required, and if you don't do that, you will be penalized with some points because it is something you need to learn to practice. All the rules for the programmers, you need to learn to practice them. Now, we need to understand writing conditions, how to write the conditions. To write the conditions, we use simple inequalities because usually the conditions are checking something to see if it is bigger than something else or smaller than something else. So common operations are inequalities for making these conditions. So we need to understand how to write those conditions. So here is that. If I write x greater than y, then I'm asking system to check and see if x is greater than y or not. So it's a condition, and if x is actually bigger than y, it'll be true. It'll evaluate to be true. This means x less than y. Greater than or equal will be written this way: the greater than symbol and then equal sign next to it. That means check to see if they are greater than or equal. Less than or equal will be written this way. So let me go to the board and explain that if you write x equal to y, this has a meaning. This means copy y into x, right? It's an assignment statement. So this cannot be a condition. So if I need to say, check to see if x and y have equal values, that condition is written with the two equal signs. This means check to see if y and x have equal values. So this can be in a if statement as a condition. If this is true, that means if x and y have equal values, then do something like x equal to x plus y or whatever you want to do. You will write that statement after that. So this condition means check and see if they are equal. So it's a question whether they are equal or not. This is assignment, which means copy y into x. And students very often write this by mistake. If x equal to y, then whatever they want to do. So if you write this, unfortunately, it will not be reported as an error by the system because x equal to y is a valid statement. That's valid. So this basically says assign y to x and then see if this the value here is true. And that will be evaluated as a true or false based on something else. I'll explain why it will work right later after we learn all of these. If I explain that at this point, it may not be clear, but this will not be reported as error. And it is wrong. It is not checking to see if x equal to y or not. It is checking something else. So you cannot write that, it's wrong. So if I need to say, check and see if x is not equal to y, then it'll be x not equal to y. We read exclamation as not. In C++, exclamation always means not. So this means x not equal to y. So if x is actually not equal to y, this condition will evaluate to be true. So if x is, let's say, 7 and y is 2, and if I write if x not equal to y, see out y, then this condition will be true because x is not equal to y. X and y are not equal. So therefore this condition is true and therefore this will be executed. And that's how it works. So the equal means question, are they equal? And not equal, exclamation equal means are they not equal? They're questions. Okay, so let's see some simple examples. If n1 has 2, n2 has 5, then n1 less than n2 is true, and n1 equal to n2 is false. If x has 2.5, y has 1.5, then x greater than or equal to y is true. That's how they will be evaluated. That's just simple example. We'll be doing more examples later. Can we compare characters? Yes. If we compare characters, the equivalent numbers will be compared. The character A is same as number 65, if you remember. So if you compare character A and character B, you're comparing 65 and 66. So 65 is smaller than 66, so character A is smaller than character B. So we can simply write simple character comparisons in our programs like this. Let me write something on the board. I can ask the system to compare character A and character C. Then you have to write A in quotes less than C in quotes. Otherwise, they will be treated as variables. So you have to have quotes around them to make them values. So now I'm comparing A and C, and if I say if this is true, that means it has to see if this is true or not, and it is true. A is 65, C is 67, so this inequality is true. The equivalent characters, numbers will be compared, and therefore, even if you're putting some letters in alphabetical order, you can compare the letters and the numbers will be compared. So as you can see, A is smaller and B is bigger than that, C is bigger than that. That's the order. Alphabetical order is same as the order of the letters. Okay, let's see. Some examples. Letter A less than C is true because A is 65, C is 67. And character A not equal to 65 is false because character A and 65 are equal. So not equal will be false. Okay, so let's do some simple examples. My first example is about grade. So let's say I have a variable grade holding the grade of the student, and I want to write a statement that says, if the grade variable has a 60 or better, then write the word pass on the screen. I'm writing grades now. So I want to write the word pass. If the grade is over 60, then this is a statement. If grade is greater than or equal to 60, see out pass. Anything I put in double quotes will be written as is. So that'll write pass if the grade is over 60. So let's try another simple example. If val is a negative number, I want to replace it with positive number. In other words, I'm doing absolute value. I want to replace val with absolute value. That absolute value is same as whenever it's negative, you want to drop the negative. So I can do it this way. If val is less than 0, then val equal to -1 times val. So that will make the number positive. It will replace val with the absolute value of the original value. I don't need to write anything about val positive because if val is positive, you don't need to do anything. To do absolute value, to have absolute value stored in val, if it is positive, I don't need to do anything. So I don't write anything about val being positive. I only need to write if val is negative, replace it with -1 times val. That's all I need to do to replace it with absolute value. Another example is if val is negative, I want to write the word negative on the screen and also increment val by 10. I need to do two things. Then I have to put bracket around the two statements. If val is less than 0, see out the word negative and then increment val by 10. Just add 10 to val, put it back in val, then you're incrementing by 10. Okay, so these are simple examples. So let me ask you a question now. If I want to write the values of two variables, the two variables are ch1 and ch2. And these two have some characters stored in them, some alphabets stored in them. And I want to write these alphabets in order, in alphabetical order. Can anybody tell me how to do that? I want to write statement to write the values of these two variables in alphabetical order.
A is less than B and B
No,
is,
no, no A, B. CH1 is a variable that has some alphabet in it. CH2 is a variable that has some alphabet in it. I can compare CH1 and CH2. Is that what you mean?
yeah,
Okay, so I need to say if what?
CH1
Okay,
is less than,
okay. Yeah, you can compare either way and work it out. So
uh,
CH1
less than CH2,
then what do we want to do if that's
then
true?
CH2 is greater than CH1.
No, 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 no. If this is true, you want to do something. What
Display C out
out?
CH2 is no
No,
CH2.
CH1 first. We want to write them in alphabetical order. So CH1, the smaller one has to go first, right?
Uh-huh.
Okay. So write CH1 first, and then ENDL, then write CH2, right?
Can you further explain the ENDL more? Because I always just put them at the end, and then sometimes I get confused when to put it. I get really conflicted on when to put it in like the
Yeah,
middle of the
anytime
statement.
you want to move the cursor to next line, you write ENDL anywhere.
Oh, okay.
So I want to write the two letters, whatever the letters are in CH1 and CH2. If CH1 has a W and CH2 has a Y, then I want to write the W first and the Y next underneath that.
Oh, okay, okay.
Okay, that's what I'm doing. So write the CH1, ENDL means go to next line, then write CH2. Okay, that way it'll write this way. Okay, you following me?
Yes.
All right. So now it's not finished yet because CH1 less than CH2 may not be true. If it is not true, it's not going to write anything. Understand?
If it's not true, then
Do you write another if statement?
Another if statement. Very good. Yes. What do I say?
If CH2
Less than
less
CH1.
than 1, C
Right.
out CH2
CH2 first. Right.
and line CH1.
Right. And line CH1. Exactly. So these two statements do the job. They will write those letters in alphabetical order. That's very good. So let's move on to see. So the next slide is basically this example right there. So move on to next example, which is application. Suppose that a business wants to give raise to those employees who are making less than 20,000. So they want to raise the salary by 6% if the salary is under 20,000. Otherwise, do not change the salary. So those who have more than 20,000 will not get the raise. Okay, so we need to write a program that will get the current salary from the user and compute the new salary and write it on the screen. All right, so here's how the program goes. Float salary, declare the salary, ask the user to enter the salary, C in salary, that'll get the salary stored in the variable salary. So now the variable salary has the current salary. Then I need to say, if the current salary is less than 20,000, then calculate 6% of the salary add it to salary, put it back in salary. That's how you raise it by 6%. 6% of salary should be added to salary and put it back in salary. So the salary has been now raised by 6%. Now that's done only if the salary is under 20,000. If that condition is not true, then this statement will not be executed. And in that case, original salary is still there. So I say see out new salary is salary. That will write the new salary if the salary was changed. Otherwise, it'll write the old salary as the salary, which is what we want to do. So regardless of whether the salary was raised or not, you want to write something on the screen. So if the salary is same as the original one, then that is the salary of the person. If the person deserved the increase, then the salary has been increased already. So see this, the same variable salary is used to hold the salary, new salary. It works better that way. Very common mistake students make is calling this new salary. If I use the name end salary to mean new salary to show the value, then if I write, then I have to write end salary here, right? The new salary is end salary, end salary. Okay. Then if the person didn't get the salary increase, nothing will be, nothing can be written on the screen. End salary has no value. Understand what I mean? If this condition is not true for somebody, then this statement will not be executed. In that case, end salary has no value. And in that case, this statement will fail. There is no value to write. So compiler will pick up on that and it'll give you a message. So that's why it's important to use the salary itself to hold the salary, even if you increased it. That way, when you write the salary here, whether it was increased or not, the salary has a value to write. The program will be correct either way. So that was common error, and I'm sure some of you will be making that error, and I'll have to bring that up again. Okay, so now we need to understand a programming technique. The programming technique, this programming technique is going to come up later. At this point, we can only work with small amount of data, but later when we are ready to work with large amount of data, like 200, 300 data, even then, the same technique will apply. So we will be using this technique all the time. And so I need to introduce that technique now, finding minimum or maximum of several numbers. So let me make up a simple example on the board and explain the idea first. If you have some variables with some values, and if you need to find the smallest of those, so let's say there are 4 variables, 4 variables, let's use W, X, Y, Z. This technique will work no matter how many data you have. So I'm going to make up some numbers to make sure you understand it. So let's say I'm trying to find the smallest value of these. So let me put some value like 10 here, 8 here, 9, 15. Okay. So what we need to do is find the smallest. And the same technique will apply for finding largest of these. So I want to find the smallest and print it on the screen. But we don't know, when we write the program, we don't know what values are there. And so whatever the values there are, the program should work and find the smallest. So here's the technique. You create another variable called min. And you just copy one of the values. You can start copying just the first value into it, 10. So initially you take the first value as your smallest value. Then compare that to the next. Compare the min to the next. Do not compare each other. If you compare each other, there'll be too many comparisons and you will get lost in the comparisons you will, at some point you won't know what to compare next. So don't do that. That's a common wrong way. You only compare the min to each one. And if any one of them is smaller, you pick that up. So compare the min has 10 now, compare the 10 to 8, compare these two. And is that 8 smaller? It is smaller. So copy that, erasing the 10. Now you have 8. Now compare the min. Min has 8 now. Compare that to the next. Is that smaller? If it is smaller, you're going to copy that. It is not smaller, don't copy it. Compare that min to next. The next one is it smaller? No, so don't copy it. And we are done. Now, so we have compared to everything. And whenever something was smaller, we picked it up. And can you see that we have the smallest? And if the 9 was a 6 instead, then when I compared the 8 to 6, the 6 is smaller, then I would have taken the 6 into my min. 6 will go into min. After that, 6 will be compared to the 15. The min is always compared to everything. And 15 is not smaller, so I'll have the 6. So min will have the smallest after this. So let's see how to write the program. W, X, Y, Z have the numbers. So where do I begin? I create my int min and do what? Anybody? What do I write here? Int min equal to something?
W.
Equal to W. Semicolon. What's next? W, X, Y, Z. All of them have some values. We don't know what they are. And I copied the W into min. What do I do next?
Do you put if X is less than W,
Less than min.
less than min?
Right. You don't compare each other. You always compare them to min. Okay. If X is less than min.
C out X.
No C out.
No.
No C out. I just want to find the minimum. And you compare the min to X. If X is smaller, you want to take that value into min.
So then min equals X.
Min equal to X. You got it. Okay. That takes care of that first comparison. The min is compared to X. What is next? I'm not done yet.
Would you maybe have to start a second if statement?
Uh-huh. Right.
If min is
Min,
less than,
If y is less than min.
Y
yeah,
is,
that's what I meant.
right. Y is less than min. Then
Then min is less than y.
no.
Y
Min is
greater
equal to
than-
Min
y.
is equal to y.
or y is greater than min.
No, just one comparison is all you need. Y less than min, we have already compared Y less than min. If Y is less than min, then we want to copy Y into min. Okay. And somebody said that right. If Y is less than min, then copy the Y into min. That's what I'm doing by saying min equal to Y. All right, you understand? I took my min in the min, I copied the W first. You can copy any one of them to begin with. So I copied the W first, and then I'm comparing X to min. If X is smaller than min, then copy X into min. In the same way, I copy Y, I compare Y to min. If Y is less than min, copy Y into min. If Y is bigger, we don't need to say anything. We don't need to say anything about bigger. Only if Y is smaller, it'll copy. If Y is bigger, it won't do anything, right? We don't need to say anything about it. We only need to say if Y is smaller, copy that into min. Okay, what should be next?
If x is less than min. I mean, if z.
if Z is less than min, right?
And then min equals Z.
Min equal to Z, right? Min equal to Z, and that's it. And this process will work even if you have 10 numbers, or even if you have 200 numbers. But if you have 200 numbers, you have to write 200 of these, but there are better ways to write that. That we will learn later. Later, we will learn how to handle large number of data. For small number of data, this will work. As you can see, let me use the same example again. 10, I have 10, 8, 6, and 15. So initially, min is taking, so right here, W10 is copied into min. So min is getting the 10 copied. After that, the x has 8 and min has 10, and x less than min is true. So therefore, the 8 is copied into min. So min was 10 before, now it's 8 because 8 is smaller. So I copied. The 8 is copied into min. Now we are comparing y to min. Y has a 6, and so y less than min is true. So therefore, y is copied into min, and so now we have 6. And then we are comparing z to min. Z is 15, min is 6, and z less than 6 is not true. So this copying will not be done. Because this condition is not true, so copying will not be done. So what do we have in min? We still have 6, and we have the smallest number, as you can see. Min has the smallest number from the list. So this is the technique, and you have to remember to use this technique for finding minimum or maximum, regardless of what you're doing. But very commonly, students forget this technique and they start comparing each other, and that's not going to work. How many comparisons are there? Do you have to, if you compare each other, W, X, Y, Z, you compare them all, how do you determine the smallest by comparing each other? It's very hard. You won't be able to finish the program correctly. This simple technique works no matter how many numbers you have. And always remember to apply that.
Professor?
Yeah, I'm sorry.
So for the max, you would do max and then do greater than?
Yes, max will be similar. Okay, let's see. Suppose that we want to find the max. Then you start by copying the W into max. Okay, so let me write it at the bottom. So you start by saying int max equal to W. And what would be the next statement? Anybody? If
X is greater than max,
greater than max, right?
max equals X.
Max equal to X, exactly, you got it. And then proceed to write the same statements for the other variables. So it's just a small change to get the max. So whether you're finding minimum or maximum, this method applies, and it works. So here is the program. I already went over that. This program is an answer to the question that says, write a program to get 3 numbers from user and then to find the minimum of those and write it on the screen. Okay, so I need to ask the user to enter 3 numbers, read them into N1, N2, N3. Then minval is getting copy of N1. Any one of those you can copy, and then you have to compare to the others. So copy the N1, and then N2, if N2 is smaller than minval, copy N2 into minval. If N3 is smaller, copy that into minval. After that, whatever that minimum was, minval has it. So simply write minval on the screen, and that's and you're done. Okay, so next thing is, so now more if statements are coming up, but before we understand more if statements, we need to understand Boolean type data. So let's understand that next. The logical values, there are two logical values. True and false are the ones we call logical values. Just like integers and floats, we have arithmetic we can do with them. We can do arithmetic with true and false also in programming language. Now, this is something that is not in math. This is very typical computer science. We can do math with true and false. So the true and false are called Boolean values. We can also call logical values, but the official name is Boolean values. And therefore, if you need to store these values in a variable, then you declare that variable as Bool type. Bool is a data type, just like float, int, and char. In the past, we learned 3 data types: float, int, and char. Now we are learning another data type, bool. So if I declare a variable as bool, then that variable can hold the values true and false in it. So we can store a true or a false in it. That means we can actually assign a condition to the variable that is bool type. So I just wanted to illustrate that here. So I have a simple example here. X equal to 7, y equal to 4, and then I declare w as a bool type. So in w, I can store true or false, the value true or false. And what is interesting in C++ is you can actually write a condition on the right side of an assignment statement, x greater than or equal to y. So it will, and then I have w equal to whatever that is. So this is something you don't write in other languages. C++ and Java allow that. So this will be evaluated first. So it is going to recognize the fact that there is an equal sign and there's a greater than or equal to sign in this one expression. So what should be next? And that's why the system has been given an order of precedence as to inequality and equality. Assignment, inequality and assignment, which one should be done first? The system has been instructed to do the assignment as the last one. No matter what expressions are there, everything else have to be done first. Assignment is the last. So therefore, it will do this first, which is a condition. And what is the value of that? Is that a true or false?
True.
True. X is 7, y is 4. So x greater than or equal to y is true. So that word true is being stored in W. W actually has the value true in it. Can I print the value? Yes. If you print that value using cout, you will get the word true printed out. So it is valid to use the Boolean value. The Boolean value can be printed if you need to. And the Boolean value can be used in an if statement, because if statement is supposed to have a condition. Whatever you write in parentheses has to be a Boolean value. So instead of writing x greater than or equal to y in this parentheses, if I just write the w, that'll work. Then it means if w is true, then do this. That's what it means. If w is true, then do this. So w can be a Boolean type variable holding a true or false. Then you can write if w, that means if w is true, then do this. And that is a valid statement in C++. So let's see the true, if you convert these logical values to integer values, remember you can convert anything to anything, right? We converted integers to floats and float to integer. We did that before. In the same way, you can convert true to integer and false to integer. If you convert true to integer, it will be 1. False will be 0 when you convert, only if you convert it. If you simply write the value, Boolean value, it'll be true or false. But if you convert it and write, it'll be 1 or 0. So you can assign a logical value to an integer variable, and then it'll be converted. So for example, let me use the board. Okay, so let me ask you a quick question. Suppose that I say x equal to 9, int x equal to 9, y equal to 2, and then w. W is also int type. And then w equal to x less than or equal to y. And see out w. Okay, what will be printed?
Zero.
0 will be printed, right? Very good. Okay, so that's because for those who don't see, let me explain. X is 9, y is 2. So this statement, when the system executes this statement, it knows the assignment is the last. Everything on the right side of assignment have to be done first. So it'll do this first, and x less than or equal to y will evaluate to be false. X is not less than y, so this is false. The false is converted to int when you assign it to w, and therefore it'll be 0. So when you print it, it'll be 0 will be printed. Okay, so here's a similar example. See out log, and what will be printed?
One.
1 will be printed in this case because m less than n is true, and true converted to integer will be 1. All right, moving on to next example. Here's an example in which I'm using Bool type variable. Val1 is 5.3, val2 is also 5.3, Bool type logic, and then I'm assigning val1 less than val2 true logic. Okay, what do we have in logic now? Anybody?
False.
False. Val1 less than val2 is false. They're equal. So therefore, logic has the value false. We didn't convert it. Logic is a Bool type, so it has false. So now I am couting for logic. That'll be false. It'll write false. And then int logic. What would that be?
0.
0. And will there be a word yes printed on the screen or not?
No, because it's false.
Because logic is false. So this cout statement will not be executed. So nothing else will be printed. Only the output of this will be just the false, the word false, and then a 0. Right? Everybody see that? The word false and 0. Okay, so now the warm-up exercise. What will be the output if the value of val1 is changed to 4.3? This changes to 4.3.
It's going to be true, 1, and yes.
True, 1, and yes. Right. On two separate lines.
Yeah.
2 separate lines, you have true, 1, and yes. Okay, very good. Excellent. So that is where I'm going to stop. And I will post if I'm going to post assignment, you will see the link this afternoon, sometime this afternoon. And if there is no link posted today, then that means there's no homework, because I don't know whether we are ready for the problems or not. Most likely we are ready for some problems, so I'll post them. So do them before next class, and then so enjoy the rest of the day and enjoy the weekend. I will see you Monday. If there is an assignment posted, please do that.
Thanks, Professor.
Yeah.
Bye, Professor.
Bye-bye.
Thank you, Professor.
Thank you, Professor.
Yeah, thank you.
Professor.
Yeah.
The exam on Blackboard, it won't let me see which questions I got correct or incorrect.
In other words, you're not able to see your exam.
Yeah.
Okay. When you go into the grade, my grade section, next to the exam, there will be a little icon, a yellow icon.
Uh-huh.
That's what you need to click at.
Okay.
Okay. That'll bring up the test.
Yeah. I'm gonna try right now.
Okay.
Okay, I see. Thanks.
All right. That's it. Have a nice one.
Yeah, same to you. Bye.